The objective of this presentation is to explain the innovative new product Profhilo based on IBS's patented technology to obtain cooperative complexes of hyaluronic acid with high and low molecular weight, which through their sophisticated production method provide new unique actions to improve skin laxity. I will describe on the one hand how these production objectives were achieved, and secondly, what we can expect from this innovative product. What is Profhilo? It basically relies on a component of a hyaluronic acid of high molecular weight, in particular exceeding 1,000 kilodaltons, between 1,100 and 1,400 kilodaltons, and a component of low molecular weight, around 100 kilodaltons. The two components of hyaluronic acid are not simply mixed, but, as we shall see later, undergo a special thermal treatment to optimize the interactions between their chains. In the physical process that develops, which does not include any technology producing chemical reactions, the two chains are combined and integrated, resulting in a high concentration of hyaluronic acid, specifically 64 milligrams of hyaluronic acid in 2 milliliters, a concentration considerably higher than in other products currently available on the market. Therefore, the objective of this presentation is to describe how we have obtained such a high concentration of hyaluronic acid while maintaining a manageable extrusion. The rationale behind the use of hyaluronic acids with different molecular weight stems from a review of the scientific literature, which in recent years has surpassed the limiting views that regarded the low molecular weight hyaluronic acid as potentially harmful to cell tissues, and instead found that the fragmentation of hyaluronic acid is an organic and biological active process present in any metabolically effective tissue. And therefore, it is important to optimize the presence of the two components. The low molecular weight component, in its interaction with ligands, has a function of stimulating cell metabolism, and thus a deep hydration function. On the contrary, the high molecular weight component, thanks to its viscoelastic properties and due to its structure and its absorption of water, can act as a true and proper scaffolding and give a lifting type support function. So there is a rationale in the use of low-weight hyaluronic acid, which becomes a stimulant, and a rationale in the use of high-weight hyaluronic acid, which becomes a real support to the skin. The technological development of Profhilo with the innovative protocol for obtaining this substance was followed by a study to evaluate the biological properties of the hybrid cooperative complex. And in a very interesting way, the scouting for these possibilities has demonstrated Profhilo's remarkable bioremodeling ability, different from that of other types of products based on hyaluronic acid. If we want to find the rationale behind this diversity, and also the interest in specific applications, we must remember that no chemical cross-linkers are used. Therefore, if the motive to increase the duration of hyaluronic acid at the application site has created the development of many new compounds, and specifically the widely used fillers, we know that the duration is a result of a chemical reaction between the chains of hyaluronic acid, which create bridges or a series of points between these chains that make hyaluronic acid less accessible to enzymatic breakdown. but with the presence of a substance not normally present in our body. In our case, through a chemical physical process, but not a chemical reaction, we are able to optimize the cooperation of hydrogen bonds between the chains, which results in a very tightly bound hyaluronic acid hybrid complexes, ultimately less viscous and therefore more easily extruded through fine needles, making its use in the clinical practice very effective. The other point, which will be discussed later in this presentation, is the slow release of the low molecular weight hyaluronic acid, which reduces the inflammatory response. In particular, we will show data from in vitro tests performed with primary keratinocytes on the most important aspects of the cooperative hybrids of hyaluronic acids with high and low molecular weight is their resistance to hyaluronidase. In fact, in our tissues, this enzyme is responsible for the degradation of hyaluronic acid. When a cross-linked hyaluronic acid is used, it is not subject to hyaluronidase action due to their chemical bonds. In the cooperative hybrids, we were able to demonstrate that deep interaction between the two chains changes the appearance of the hyaluronic acid, at least for the biological action of the enzymes. So, if linear hyaluronic acid is degraded by bovine hyaluronidase by even 50% in a few hours, in the cooperative hybrids, the fraction of high molecular weight is not attacked by hyaluronidase and has a hydrolytic resistance up to 8 times higher than the linear hyaluronic acid. This places complex hybrids between linear hyaluronic acid and the cross-linked hyaluronic acid, ensuring their longer duration in the place of application when compared to linear hyaluronic acid. In this slide, we use a slightly more technical method to describe the exceptional condition, which actually is the basis of the uniqueness and patentability of these new complexes. In the figure shown, we report the flow curves obtained through the use of a rheometer. In the rheometer, the gel solutions of hyaluronic acid are exposed to a forced flow. During this mechanical treatment, the chains of hyaluronic acid are assembled, one close to the other, in parallel, and their viscosity decreases with the increase of the shear rate. This is correlated to the extrusion in time. When we begin to extrude a viscous gel through a syringe, we must impose a high force. As the gel flows through the syringe, the resistance diminishes. A very interesting point in this graph is that we can track the increase in viscosity typical of linear hyaluronic acid and compare it with what happens in the hybrid complexes. The blue triangles represent the rheological flow curve of a linear hyaluronic acid dissolved in a saline solution. We see that with an increasing shear, that is, when we go to the right along the horizontal axis, the viscosity decreases. The open triangle represents the same solution when it undergoes sterilization, as it is the case for any medical device. You see that there is a jump in the viscosity of about 3-4 times. You see that we are about at 100 Pascal per second in the blue triangles at the beginning, when we start pushing the plunger of the syringe. As this is a logarithmic scale, we are at about 20 Pascal after sterilizing the product. If we add low molecular weight hyaluronic acid to the high molecular weight linear hyaluronic acid, simply by mixing them, we increase the initial viscosity represented by the pink squares. But when the hyaluronic acid undergoes the patented thermal treatment, there is a sudden and remarkable drop of the dynamic viscosity. The product becomes more fluid, easier to inject, and can be more easily distributed under the skin. If you see, blue curves fall within the pink curves. But again, since on the left, on the vertical axis, we have a logarithmic scale, we have a jump of 30, even 50 times, and this allows us to use a concentration of hyaluronic acid which would not be otherwise injectable through a needle. A particularly interesting aspect, which concerns the development of Profhilo, is the reduced inflammatory response of this product. This characteristic has been demonstrated by in vitro tests using human primary keratinocytes and evaluating the response to the administration of hyaluronic acid of low molecular weight, high molecular weight, and of the complexes. The graph shows the gene representing data, or RNA, relative to the TGF-beta, which is one of the cytokines involved in the inflammatory response cascade. It is worth mentioning an important difference in behavior already in the short term, because after only 4 hours of contact, the low molecular weight hyaluronic acid elicits a response 4 times higher than the control group for high weight hyaluronic acid, while the response for the complex is practically non-existent. After 16 hours, when the cells have begun their process of remodeling and have started to degrade the matrix of the cell layer that we created in vitro to duplicate and migrate, we need to find a minimum of cytokine response because this is part of the homeostasis of these cells. However, it is important to note that the RNA transcript responses are similar with respect to high-weight and low-weight hyaluronic acid and the complex. The latter, in any case, even if in a less significant way, generates the lowest response. What does this mean? It means that in the deep integration of low molecular weight and high molecular weight hyaluronic acid, we were able to create a system of slow release for which the cells, initially, are not aware of the presence of a low molecular weight hyaluronic acid and therefore are less stimulated to generate an inflammatory response. At this point, we must explain this technology in greater detail. That is, what has been deemed patentable by the Patent Office, which evaluates innovativeness and how surprising the results are with respect to what could be found in existing literature. The production process of Profhilo, with respect to what could be found in existing literature, includes a first phase in which the populations of high molecular weight and low molecular weight hyaluronic acids are chosen and mixed. In this phase, it is important to assess the mixing time and the amounts for each component. We have demonstrated the effectiveness of interaction for such substances in a very wide range. We take a portion of hyaluronic acid at 1,400 kilodaltons and another at 100 kilodaltons in a 1-to-1 ratio. In particular, in Profhilo, we take 60 milligrams per milliliter of the high molecular weight hyaluronic acid and another 60 milligrams per milliliter of the low weight, and we mix them. Once we have mixed these amounts of hyaluronic acid, obviously in a suitably defined saline solution, to ensure that there is no osmotic effect when injected subcutaneously, and therefore a burning effect, these substances are processed through a temperature variation. In particular, we increase the temperature so as to give sufficient energy to the chains so that they can move and allow the interpenetration of low molecular weight chains in the network of high molecular weight chains. It is important to remember that the longer the polymer, the greater the number of contemporary hydrogen interactions will be, and therefore we will have a much higher viscosity, because the chains will automatically interlock with one another. In fact, a product with lower molecular weight is less viscous. Once we've heated the mixture containing the high and low molecular weight hyaluronic acid and have given sufficient time to break the hydrogen bridge interactions between the long chains in order to integrate the smaller chains in their networking, we can let the mixture cool. In the cooling, we will find a minimum requirement of energy, in which the interactions between the short chain and the long chain are optimal. The presence of these optimal interactions is characterized, on the one hand, by the sudden drop of the dynamic viscosity, and on the other hand, by a chromatographic fingerprint profile that is uniquely distinguishable from the other hand and the other simple mixture of the two substances. This relationship has allowed us to file a patent application, also at the European Patent Office, and it is what defines the formation of new hybrid cooperative complexes of hyaluronic acid based on these two populations of molecules that, after the thermal treatment, become a new entity. The result is a product more resistant to the attacks of hyaluronidase, with a dynamic viscosity considerably lower than expected in current scientific literature, and in addition, the slow release of low molecular weight hyaluronic acid without generating an inflammatory response. These special properties of the hyaluronic acid hybrid complex, therefore, exceed the effect of a simple mixture of high weight and low weight hyaluronic acid, allowing a greater resistance to the attack of hyaluronidase in vivo, and thus a long-lasting effect of greater persistence of the injected product. At the same time, we have a stimulating action due to the release of low molecular weight hyaluronic acid, which takes place slowly, therefore avoiding an inflammatory effect on the application site. At the same time, the immediate presence of the high molecular weight supports the skin structure and thus obtains a firming effect. In conclusion, we have a complete remodeling of the structure and obtain effects exceeding those of any other product.